So the fifth video. This time we're going to look at the intersection points between two linear functions. Now this is really important, obviously, because here we would like to know where the equilibrium point in the market is, i.e. where the supply equals demand. Now we can see from the graph because the graph is so clear, but let's pretend we don't know and that we need to solve this problem. So let's find, and this is what's known as solving simultaneously. We're looking for the combination of P, for the unique combination of P and Q. That's the same for both of these lines. So let's look at the supply curve first. What's our equation? The equation is P equals 1 because it crosses the p-axis at 1. If we look at the gradient, it looks like a gradient of 2, doesn't it? It's going up 2 for every 1 across. So that's a plus 2q, so that's our supply function. Let's look at our demand function. It is P equals 6, but this is a downward pointing one, as it should be because it's demand. So it's minus, and we can see that P decreases by 6 as Q increases by 2. So it's an inverse relationship. As P goes from 6 to 0, Q goes from 0 to 2. So we could write that as 6 over 2Q, but that really implies that it's P equals 6 minus 3Q. It's a gradient of 3. So we want to find the point where these two functions intersect. Now, if P is equal to this and P is equal to that, then at our equilibrium price, we know that that must equal that. So we can set it equal. Okay, so back to our basic linear algebra. There are other videos on that for manipulating this, but let's have a go at this. So we have plus 2q's on that side, but we have negative 3q's on this side. So we really want to get these negatives over to the other side so that they become positive. So let's do that. So now we've got 1 plus 2q plus 3q equals 6. Now, whenever we change something to the other side, it changes the sign. So that's our price of moving over the equal sign, is to change the sign. So it becomes positive here. So now we've got 1 plus 5q equals 6. We're trying to get q on its own, so we want to move this 1 to the other side. It's positive here, so it will become negative on the other side. So we've got 5q equals 5. But we're not interested in what 5q is equal. We're interested in what 1q is. So because the q has a 5 in front of it, we divide by 5. Yeah? Because if something is multiplied by 5 and we divide by 5, you get just the basic q. So we've got q equals 1, which we can see from the graph. We can see the equilibrium point is at the point q equals 1. So if q equals 1, we can take either of those two functions. Here we go again, P equals 1 plus 2q, and everywhere there's a q there, we put in a 1 instead. We substitute in a 1. So we see that P equals 1 plus 2, P equals 3. So it looks like the equilibrium point is that q equals 1, P equals 3, which we can see from our graph. So let's do another one. Here's another pair of functions. What's the supply function? Well, here the supply function is P equals 1 plus, it is going up 2, looking at the points where it goes through the corners, it's going up 2 for every 4 across, well, or actually it's going up 1 for every 2 across, even simpler, so it's a half q. Okay, the change in P is 1 every time Q changes by 2. So it's a shallow curve or line. Now the demand function is P equals 3. We notice it's going downwards. It's a negative gradient because P is decreasing by 3 every time Q increases by 6. So that's 3 over 6 or 1 over 2, depending on which squares you look at, but the value is the same. So again, we want to set these equal, so we know that this is equal to this at the equilibrium price. So we've got 1 plus half q equals 3 minus a half q. Good. So we've got negative q's here, positive q's here. So this is the side we want to get the q's onto. So if I move this minus half q to the other side, it will become a half q. So I will get this. And a half q plus a half q is a whole q. Now we want to get this 1 over the other side because we want to get q all on its own. So we find out that q equals 2, which is exactly what our diagram tells us. So if q equals 2, we can substitute this into either of those equations. P equals 1 plus a half 2. I'm putting the 2 in brackets because I'm substituting it into the function. So P equals 1 plus and a half of 2 is 1 equals 2. So we can see that P equals 2 and Q equals 2 at the equilibrium point. And here's yet another one. So the supply function is P equals 1. It has a gradient of a half. P is going up by 1 every time Q goes up by T. So it's in a ratio of 1 over 2Q. Demand function, as always, is downward facing or downward leading. P equals 4. And what's the gradient here? Well, it's going down 1 for every 1, or 2 for every 2, or 4 for every 4. Either way, the ratio is 1 over 1, so it's just 1q. But we never write 1q in algebra. We just write q. 1q equals q, and in 1x equals x. We don't need to write the 1, plus we'd rather not because it makes us look like we're not experienced algebra users. So again, we want to set these two equal to find the equilibrium point. So we got 1 plus a half q equals 4 plus q. This time, both the q's are positive, which tells me I've made a mistake. That's minus, because it's coming down. That was a bit of giveaway. Yeah, because the gradient is coming down 1 for every 1 across. It's a negative gradient. So, because I want my q's to be positive, I can see that I want to take this 1q over to there. So I'm going to have 1 plus a half q plus a q equals 4. Now, a half a q plus a q is really 1.5 q's. But we don't write, in algebra, we don't tend to use mixed fractions. We'd rather write that as 3 over 2. If in doubt, you can use your calculator to give you some rearrangements of fractions. I know lots of people are not comfortable with them. 1.5, if you've got 1.5 pizzas, you've got 2 halves making up the whole, and then you've got an additional half. So you've got 3 halves. 1 plus 3 over 2q equals 4. We want to bring this 1 over 3 over 2q equals 4 minus 1 is, well, let me write it longhand. 3 over 2q equals 3. So now I want to get a single q out of that. So how am I going to do that? Well, if I multiply both sides by 2, I get rid of the 2 on the bottom there. Yeah? If I double both sides, then I get 6. Yeah? Multiply both sides by 2, or whatever that number is, so that it goes away. So now if 3 over 2q is equal to 3, then I know that 3q is equal to 6. But I'm not interested in what 3q is, I'm interested in what 1q is, so it's equal to 2. So the equilibrium quantity is 2. Let's see what the equilibrium price is. I'm going to take one of those functions. 1 plus a half q becomes p, equals 1 plus a half. And I substitute in our value of q, which gives me p equals 1 plus a half plus a half times 2. Well, what's a half of 2? It's 1. So we've got p equals 2. So the equilibrium quantity is 2, the equilibrium price is 2, which of course we can see in our diagram. So here's some more graphs for you to practice with. So in each case, write down the two functions and find your equilibrium point using algebra. Freeze the screen and I'll show you the solutions afterwards. Okay, and here are the solutions. So I hope that was helpful.